Hey guys, let's continue to talking about reinforced learning. So I create a new Jupyter notebook. It will be some base and example. It is very important to understand how reinforced learning algorithm is working. There exist some advantages and disadvantages, but we need to create some simplest version without any library and neural network to cover the main idea. So we're going to use only library like NumPy and random. I mean, without any reinforced learning library. So let's run it. And next, let's imagine we have 5 indicators and 3 actions. For example, buy, sell, hold. No values per indicator would be 6. It would be categorical indicators. It means like 0, 1, yeah, like this one. And you could persist this one using pandas qcut, for example, and you could persist continuous variable to categorical, like this one. Why we need it? We need it to create a big matrix. It would be 3D matrix. And there it's very important because on too many examples, reinforced learning algorithm was working only with 2D matrix. What I saw on open source. So, for example, this one, it would be number of indicators. There would be number of value of indicators, how many values could be there. And this one would be no actions, and I would like to use only 3 actions. But of course, if we're going to use more indicators, more different value there, and more actions, our matrix would be, it's really big. Okay, but firstly, I would like to show you some with policy. Let's look on this policy. It's yeah, you see, this is our policy. Yeah, and we go to understand what is the shape. Okay, let's jump. Okay, so this is 3D indicators. And there I would like to create some state. For example, it would be 5 indicators like RCI, moving average, MACD, some another indicators with volume, and it would be the categorical values. And there I define index of these indicators, yeah, so 5 indexes. And what is the actions? For example, 2, and for example, some like reward. And we need to define some probability inside in this 3D matrix. To do it, we need to go our policy, this is our NumPy an array. We take 5 indicators, indexes, yeah, and input what is the state, what is the current state right now, and what is the actions we have right now to achieve the target reward of $10, for example. Okay, it is learning rate. It is the same what was. And next we need to update our policy. So we take, you see these indexes, state, actions, and we take this new probability there. And this one, we need to create some normalization of probability, because sum of probability should be 100%. It means 1. Yeah, it's very important, this one. For example, you see, check the sum of probability should be 1. For example, like this one, at 20%, 5 times, it would be 100% of probability. So, okay. And then what we need to do, for example, this is like some policy after optimization. You see, when we do some initialization of this policy, we create the same probability for each cell. But after optimization, we update this probability, it would be this one, you see? Okay. And another, for example, okay, let's look at the another value is not changed, it's okay. And then what we need to do, we need to run a loop to understand how we could update this policy. So let's do the same. We do some initialization of value, and we're going in the future create this data inside of environment, and then we create policy with the same, it will be with the same probability, 3D actions with the same probability. Index indicators, okay, because 5, yeah, and its index is from 0. And next we just create some random state, random action, and some random reward. The main idea to understand how this policy updated all times. Okay, then we calculate our current probability. It's the same, index indicators. The key would be the state and what is the action. Then the same learning rate, and we processed our current probability plus learning rate multiplied by reward, and then we update our policy. Then we do normalization of our policy because sum of probability should be 1, and then we need to calculate what is the most effective action inside of this state, yeah, because state could be something like that, and we need to understand that this state would be changed. It should be different values inside there, and for each combination we need to define some probability. It is the main idea. And then we calculate our average probability, and then we calculate our what is the best actions. And if you run it 100 times, and you see, for example, all times we update what is the best action depends of our policy, what we have right now. It's very simple. An example. So we're using 3D shape matrix instead of 2D shape because we have number of indicators, because I would like to use in the future, for example, 100 indicators. Next, inside this 100 indicators, each indicators could have, for example, 10 or 20, 100 of, for example, values there. It depends of metrics, but like very simple an example, I just create 6 categorical variable, and what is the actions, number of actions, so 3D action, 3D shape. Okay, so, and it means we update our policy every time without any neural network. And for example, how to use this policy. For example, we need to use only state. Right now, for example, we have some state of these indicators, and we input this state because index indicator will be the same all times, and we input only state, and we take our probability from actions, and then we calculate what is the best action from those probability, and after that we return what is these actions. We have 3 actions, for example, like buy, hold, and sell. So guys, I hope it should be very useful for you to understand the base idea of reinforced learning. See you next time.